So renewables and clean energy are going to be the hot topic for a very long time, and we all know why that is. And what that means is it's going to be a bit of a Wild West show while everybody shouts out that they've got the answer and it's the latest and greatest. And the newest one to come out is something called LPD Clean Energy. Now, LPD is the brainchild of James Goran van Grozny, and it stands for Lunar Pulse Drum. Now, what James means by Lunar Pulse Drum is the tide. When the tide comes up, if you capture it, you can direct it into a vessel to create pressure. You then open a lock, that pressure goes over a turbine and you generate equally. As the tide falls, then you create a vacuum, open the lock and a generator will generate again. And James is saying that this is his idea, a new idea, and it was inspired when he was in the bath with an Archimedes Eureka moment. Now, that may or may not be true, but James's idea actually isn't that new. What I think we need to do is have a look at how it fits in, what other things are around it, and we can see that James's idea has actually been out there for quite a while.
And countries with long coastlines are beginning to look more and more at accessing the available power of the sea. Now, the sea power actually breaks down into two main sources. You can get power from the waves, so you can get power from the tides, and they come from different places. The power from the waves is essentially from the wind hitting the waves and knocking the water, and that knocks the next bit of water on, creating the wave. So the fundamental source is wind, and of course wind is generally created by solar. So there's a concentration of energy going on, and of course water as a fluid has a great deal more mass than air, so that concentration is extremely efficient, and you get this heavy mass moving where the solar to wind to wave conversion has been done. But essentially it arises from the wind, and the wave is created by the movement of wind across the surface of the water. The characteristic of the wind, that is how far apart the waves are, how deep the trough is and how high the peak of the wave is, are determined things like wind speed and topography of the ocean floor and the depth of the water. But that wave can be captured and harnessed. Now, there are three main ways, and we'll come back to them. But there's oscillating column, oscillating body, or overtopping, and we'll go into that in a minute. The other source of power from the body of water is, of course, tidal. Now, tidal power is a gravitational power. So as the Earth rotates with the moon exerts a gravitational pull on the Earth, and that stretches the water out, and that's where we get tides from. Now, there's an effect of the sun, and when the sun and the moon are in alignment, then we get super tides. So that movement of the mass of the body of water is gravitational, while the wave itself is generated from the wind. And there are different ways of using that tidal power, mostly tidal turbines and tidal barrages. So the way an oscillating column works is there's a structure by the sea with the open bottom. As the wave comes in, the water in the structure is forced up as a column.
It compresses the air above it and it's forced over a turbine. Now, the common turbine used is something called the Wells turbine.
The Wells turbine has the blade shape so it rotates in the same direction,
whichever direction the wind is when the air blows over the turbine, kind of like a valve or a rectifier for wind.
Oscillating body generators have this kind of format. And you find them as all kinds of proformers, from floating platforms to the famous one, which is the Pelamis, which is also known as the sea snake, and it looks like this. The final classification is the overtopping. The overtopping has this sort of structure to it. Perhaps the most famous one of those is the wind dragon, which looks like this.
Basically, the way it works is when the waves hit the reflectors, they slosh over the top into a big well on the platform, and that collects the water. The well in the centre then releases the water through those plungers and they drop down through the turbine outlet, and that is what creates the power.
Sorry, wave dragon, not wind dragon. I've clearly got wind on the brain. Anyway, typically what these oscillating body wave capture machines do is pump hydraulics or air around, and they use that to drive a turbine, and that's what generates the electricity. Now, when we come to tidal power, actually tidal power has been with us for a very long time, at least the 6th century. The Romans used it to grind corn, and it uses the power of the ebb and the flow of the tide. Now, it's amazingly similar to wind. Typically it's 2 or 3 bladed turbine anchored to the seafloor, and as the tide goes across that turbine, it drives it. Of course, there are some differences because water, being more dense, carries an awful lot more energy with it, and that turbine will turn at something like 12 to 18 RPM. You also get Savonius types, where they're just an upright in the same way that you would see a Savonius turbine. Now, tidal barrages are just what they sound like. You choose a tidal estuary, you stick a big barrage across it, the tide comes in, you close the barrage gates, and of course you get a difference in water height, and then you can open those gates and let that water flow through a turbine series and generate from it. So they're pretty much what you'd expect them to be. Now, these are just examples of things that are in construction or plans that have been made, but of course it is a hugely fertile source of research, and so there are many different types that can be actual implementations of those basic ideas. For example, we looked at the oscillating body type, and that doesn't necessarily have to be out at sea. It can be constructed on a shoreline as easily. That idea of the tidal capture by the barrage, it could easily be done as a lido by the side of the sea that just captures it at high tide and lets out the low flow of water. The turbine shape itself obviously can change, and an Archimedes screw type would be another type, particularly on that lido idea, that you could use.
But the basic ideas don't really change that much. So where does LPD fit into this? Well, clearly it's more of an oscillating column idea where you're using the waves to create a change in pressure. Now, normally that's used with waves. The idea of using it with the tide to create a pressure, well, that's kind of neat because it does create a sort of storage battery, but that's been explored as well. Calling it lunar pulse drum is more of a rebranding as opposed to a reinvention. But then wave power is a really interesting idea because of all the energy stored in it and of all the advantages of using it. Of course, it does come with its own disadvantages too. But I wanted to talk about LPD, particularly because a member asked me to do it. I hope you enjoyed the video. I hope it explains what LPD is in the general schema of wave power, and thank you very much for watching. Oh, please don't forget to like and subscribe.